The diazonium salts have general formula Rn2 positive X negative, where R stands for an aryl group and X ion stands for chloride, bromide, HSO4 negative, BF4 negative. Primary aliphatic amines form highly unstable alkyl diazonium salts, whereas primary aromatic amines form arene diazonium salts which are stable for a short time in solution at low temperature 273 Kelvin to 278 Kelvin. The stability of arene diazonium ion is explained on the basis of resonance. This is diazonium ion. Here we have triple bond. Nitrogen has positive charge and there are lone pair of electrons on nitrogen. These pi electrons take part in double bond formation and this pair of electron shifts here so that negative charge is formed here, positive charge is here, and here we will have positive charge at ortho position. Now this pi electrons will shift to this position and positive charge will come at para position. When pi electrons from this double bond shift this position, again positive charge comes at ortho position. And this can back the electrons from this nitrogen and we get this structure again. So due to this resonance stabilization, benzene diazonium chloride or arene diazonium chloride or diazonium salts of aromatic compounds are quite stable. Next we are taking method of preparation of diazonium salts. Aniline reacts with NaNO2 plus 2HCl at 273 to 278 Kelvin. The benzene diazonium chloride plus NaCl plus 2 water is formed. Physical properties. Benzene diazonium chloride is a colorless crystalline solid. It is readily soluble in water and stable in cold but reacts when water is warmed. It decomposes easily in dry state. Benzene diazonium fluoroborate is water insoluble and stable at room temperature. Let's take up chemical reactions. Reactions involving displacement of nitrogen. Replacement by halide ion or cyanide ion is the most important reaction called Sandmeyer's reaction. Benzene diazonium chloride when reacts with cuprous chloride in presence of HCl, we get chlorobenzene plus nitrogen gas is liberated. If benzene diazonium chloride reacts with CuBr and in the presence of HBr, we get bromobenzene and nitrogen. And benzene diazonium chloride, if reacts with CuCN and KCN, we get benzonitrile or benzene nitrile plus nitrogen. This reaction is called Sandmeyer reaction, and use of this reaction is if you want to convert aniline to chlorobenzene, convert aniline to diazonium salt first, then get chlorobenzene by Sandmeyer reaction. Similarly, you can get bromobenzene, first convert aniline to diazonium salt and then bromobenzene. Benzonitrile can be prepared by Sandmeyer reaction by the same method. Next we are taking Gatterman reaction. Gatterman reaction, benzene diazonium chloride reacts with copper and HCl. Product formed is chlorobenzene plus nitrogen is liberated plus CuCl is formed. When it reacts with Cu and HBr, we get bromobenzene plus nitrogen plus CuBr is formed. Replacement of iodide is not easy, so benzene diazonium chloride, we react it with potassium iodide, we get iodobenzene plus nitrogen plus KCl is formed. Next is replacement by fluoride ion. This reaction is called Ball-Schiemann reaction. Benzene diazonium chloride will react with HBF4, fluoroboric acid, results in the formation of benzene diazonium tetrafluoroborate, which on heating gives fluorobenzene plus BF3 plus nitrogen. So this is the method for getting fluorobenzene from aniline. First to diazotization followed by treatment with HBF4 and then on heating we get fluorobenzene. Next we are taking replacement by hydrogen. Benzene diazonium chloride when treated with reducing agent like hypophosphorus acid H3PO2 plus water, we get benzene plus nitrogen plus H3PO3 plus HCl. So H3PO2 is acting as reducing agent. Instead of H3PO2, we can use ethyl alcohol as reducing agent. Benzene diazonium chloride will change to benzene plus nitrogen. Ethyl alcohol will get oxidized to acetaldehyde plus HCl will be formed. Next we are taking replacement of hydroxyl group. If benzene diazonium chloride is warmed with water, we get phenol plus nitrogen plus HCl. This reaction can be used to convert aniline to phenol. Aniline will be diazotized to get benzene diazonium chloride, followed by warming with water to give us phenol. Replacement by NO2 group. For replacement by NO2 group, first diazonium chloride is treated with HbF4 fluoboric acid and we get benzene diazonium tetrafluoroborate. It is heated with NaNO2 and copper. We get nitrobenzene plus nitrogen plus sodium borofluoride. Reaction involving retention of diazo group, these are called coupling reactions and they can be used for testing phenol and aromatic amines. Here benzene diazonium chloride is reacting with phenol, this HCl will be lost and product formed will be para-hydroxyazobenzene. This group is para-hydroxy, this is azo. So para-hydroxyazobenzene is a orange color dye. Side products will be chloride ion plus water is formed. Reaction is facilitated by OH ion. Similarly, if we react benzene diazonium chloride with aniline, HCl will be lost and product formed will be para-aminoazobenzene. This is called aniline yellow or yellow dye. Side products are same chloride ion and water. Similar reaction we are taking benzene diazonium chloride when reacts with N and dimethyl aniline in presence of OH ion. The product formed is para-dimethyl aminoazobenzene. This is called butter yellow. Here also HCl is being removed, coupling reaction is taking place. In next reaction we are treating benzene diazonium chloride with beta-naphthol and HCl is removed, we get this compound by coupling reaction. The product is called phenyl azo-beta-naphthol, that is red dye. Benzene diazonium chloride when reduced with hydrogen produced by SnCl2 and HCl or sodium sulfite, which is a reducing agent, will get phenylhydrazine. Here each nitrogen gets hydrogen. This one nitrogen gets one hydrogen, another nitrogen gets two hydrogen, so we get phenylhydrazine. It is a product of reduction. Gumbag reaction when benzene diazonium chloride is reacted with benzene in basic medium on heating, we get diphenyl. And benzene diazonium chloride when reacted with sodium arsenite and HCl, product formed is phenyl arsenic acid. Next we are taking conversions. How will you convert 4-nitrotoluene to 2-bromobenzoic acid? This is 4-nitrotoluene or para-nitrotoluene. First we are carrying bromination. Now whenever you have got two groups, one of them is electron releasing, another is electron withdrawing, electrophile will attack the ortho position of the electron releasing group. And if both are electron withdrawing, then electrophile will attack to meta position to the less electron withdrawing group. And if there are two groups which are electron releasing, the more electron releasing will direct the incoming electrophile to ortho and para position. So this is the way how do we decide where the electrophile will attack. Now in this case, para position is already occupied with the electron withdrawing group. So electrophile Br positive will attack at ortho position. NO2 group we want to reduce to NH2, SnHCl can be used which will produce nascent hydrogen and NO2 group will change to NH2 group. Now the next step is diazotization with the help of NaNO2 and HCl. Temperature is 273 to 278 Kelvin. NH2 group will change to N2 positive Cl negative, that is corresponding benzene diazonium chloride is formed. We want to get rid of this group, so we can treat it with H3PO2 in presence of water, so we'll get orthobromotoluene. We want orthobromobenzoic acid or 2-bromobenzoic acid, so we oxidize it with alkyne KMnO4, CH3 group will change to COOH, so we'll get 2-bromobenzoic acid or orthobromobenzoic acid.